All right, we're going to look at parallel lines today, and the fact that they're cut by a transversal, which is a line that cuts through two or more lines. So basically, this line here, we'll call it T for transversal. On these lines, we'll cut this line here, which we'll call L, and this line here, which we'll call M. Okay. When we have parallel lines, we put a arrow on our lines to indicate that they're parallel. And it is not the same as the arrows that are on each side of the line to show that the line goes on indefinitely. So these show us that these lines are parallel. So I'm going to call this transversal T here also, and this L and this M. So we have two cases where we have a transversal T intersecting lines L and M. And in the first case, the lines are not parallel. In the second case, the lines are parallel. In either case, we have different kinds of angles that are formed. We have corresponding angles, what we call same-side interior or consecutive interior angles, alternate interior angles, and alternate exterior angles. These are based on the position of the angles that are formed by the transversal and the lines that it intersects. But there's a unique relationship between these angles when the transversal intersects parallel lines. But right now we're just going to focus on the position of these angles. So corresponding angles are angles that correspond to each other. So if we have this transversal intersecting line L, we have an angle 1 here. And if that transversal intersects line M, 1 and 5 are in the same position. They're on the same side of the transversal and above the line that the transversal is intersecting. So the corresponding angles in this case are angles 1 and angle 5. We don't know about the relationship, we just know where they're positioned. When you go down to your parallel lines, we also see that 1 is above the line that the transversal is intersecting and on the right-hand side of the transversal, as is 5. So 1 and 5 again are corresponding angles. Okay, other corresponding angles are 4 and 8. And angle 8. And always put the angle symbol in front of them. Angles 2 and angle 6. Okay, so it's based on position, nothing more than that. And angle 3 and angle 7. All right, so those are corresponding angles. They're on the same side of the transversal, above or below the line that the transversal is cutting, and they correspond from one line to the next. Next we have something called same-side interior. All right, next we have what's called same-side interior angles or consecutive interior angles. Now, same-side interior angles or consecutive interior angles are on the same side of the transversal, but they're on the inside of the lines. Okay, so angle 4 and angle 5 are same side consecutive interior angles. Again, same side of the transversal, but between the lines, on the interior of the lines that are being cut by the transversal. So angles 3 and 5, angle 3 and 6. Right, and the same goes for if your lines are parallel. These angles would be same side interior as well as these. All right, now the next are alternate interior angles. Alternate interior angles mean that we're on the inside or in between the two lines, but on alternate sides of the transversal. So angle 4 and angle 6 would be alternate interior angles. Angle 3 and angle 5 would be alternate interior angles. And with that, we also have alternate exterior angles. And alternate exterior angles are on the outsides of the lines that are being cut by the transversal, but on alternate sides of the transversal. So angles 1 and angle 7, they are a pair of alternate exterior angles, and angle 2 and angle 8. All right, so these are the positions of angles that are cut by a transversal. So whether they are parallel lines or not, They're just the positions of them. Now there is a unique relationship between parallel lines and the corresponding angles, okay? And the same side interior or consecutive interior, and the alternate interior angles and the alternate exterior angles. Right, so I'm going to use this, okay? And what we know is that when we have parallel lines, corresponding angles, which we identified as angle 1 and 5, are going to be congruent. So that's what's unique about having a parallel lines. So angle 1 is congruent to angle 5. These are corresponding angles. So angle 1 and angle 5 would be congruent. Angle 2 and angle 6 are corresponding angles. They would be congruent. And this is only if you know you have parallel lines. So you're making a conclusion about your angle relationships based on the fact that you know you have parallel lines. So angle 3 and angle 7 would be congruent. So we'd say angle 3 congruent to angle 7. And angle 4 would be congruent to angle 8. And we will be doing some examples in a little bit to see this. Same side interior angles, which are here on the inside, 4 and 5, 3 and 6, okay? They're supplementary. So this is really important. Supplementary means they add to 180. So the measure of angle 3 plus the measure of angle 6 equals 180 degrees. Same thing for the measure of angle 4 plus the measure of angle 5 equals 180 degrees. So that's the unique relationship of having parallel lines that are cut by a transversal. So that unique relationship is for those angles, or the consecutive interior angles. For alternate interior angles, which are our angles 4 and 6 and 3 and 5, these guys here, they're congruent. So we would say that angle 4 is congruent to angle 6, which then of course implies their measures are equal. Also angle 3 and angle 5 are congruent. So we can write another statement of angle 3 is congruent to angle 5. And again, their measures would be equal. So if angle 4 was 10 degrees, then angle 6 is 10 degrees, okay? And lastly, we have alternate exterior angles, and they are angles 1 and 7. And I'm marking these up here so you can see. So 3 tick marks and 3 tick marks, so they don't get confused with the single tick mark and double tick mark from the other ones. Angle 1 is congruent to angle 7. And angle 2, 4 tick marks, 1, 2, 3, 4, and angle 8 are congruent. So these are the unique relationships between our parallel lines cut by a transversal and the conclusions about your angles. So that's the unique relationship about your angles. All right, what we know is that this fact, our lines are parallel. We know that. All right, so we were working with line L and M. So L, which is a lowercase script letter that depicts our name of our line if we're not doing it by points. 2 elongated looking L symbols right next to each other. That means parallel. And M. So this means L is parallel to M. And the way I remember the parallel symbol is it's got 2 L's in parallel, so these are just a little elongated. So we have a fact. We know our lines are parallel. We are proving or showing our relationship of the angles, and that's where we're coming in with the congruence of the angles, or whether or not the angles are supplementary based on their position. So with that, we have postulates and theorems that have to be memorized. So Corresponding angles postulate. If a transversal intersects two parallel lines, then corresponding angles are congruent. Okay, here are two lines cut by a transversal. Okay, corresponding angles are congruent. So for example, I don't even need names for these angles. These are congruent. Okay, these angles are congruent. The angles under here, 1, 2, 3, are congruent. 1, 2, 3, etc., etc. Okay, so that's what this means. Alternate interior angles theorem. If a transversal intersects two parallel lines, then alternate interior angles are congruent. Here's two parallel lines cut by a transversal. Alternate interior angles are congruent. I don't need a name for these angles. I just can see where they are. Okay, if these are parallel lines, which I should have also done up here, okay, parallel lines, okay, then this angle, alternate interior angles, these are congruent. In addition, the other pair of alternate interior angles, I'll use two angle tick marks, are congruent. Alternate exterior angles theorem. If a transversal intersects two parallel lines, then alternate exterior angles are congruent. Okay? We'll make ourselves a little picture here. We'll make our transversal go this way. Alternate exterior angles are congruent. Again, I don't need the name of the angle. I just need to know where they are. These angles are congruent. These angles, double tick mark, are congruent. And they're not congruent to the ones with the single tick mark. And lastly, consecutive interior angles. If transversal intersects two parallel lines, then consecutive interior angles are supplementary. What that means, draw that a little bigger, make it this way. It means that I'm going to name these. I'll name that 4, and I'll name this 6, and I'll name this 3, and I'll name this 5. It means that angle 3 and angle 6 add to 180. So what I usually do on my picture is I'll put plus to 180. All right, a plus to 180. So now when I'm writing this, I'll say, okay, the measure of angle 3 plus the measure of angle 6 is going to give me 180 degrees. That's what supplementary angles mean. So if we know these are parallel lines, and we would have to mark it as such after we're told, or it will already be marked as such, your conclusion is about the angles. We also know that the measure of angle 4 plus the measure of angle 5 is 180 degrees. That's what supplementary is. Okay, so we have names for these theorems. Corresponding angles postulate, alternate interior angles theorem, alternate exterior angles theorem, and consecutive interior angles theorem. The names of these angles are reasons or justifications in a proof. If you cannot remember the names of these theorems or postulates, you can say, for your reason in a proof, if a transversal intersects two parallel lines, then corresponding angles are congruent. You can say the whole statement in words that mean the same thing. Okay, prefacing it with a transversal intersecting two parallel lines, then your conclusion that corresponding angles are congruent. Your conclusion that alternate interior angles are congruent. Conclusion, alternate exterior angles are congruent. And conclusion, consecutive interior angles are supplementary. So if you don't remember the names of the theorems, that you have to write that entire statement out as a reason in a proof. So most of the time, most of us will remember these names of the theorems or postulates.